I'm just going to jump back a little bit. Thank you, Justin, for that. I'm going to talk a little bit about part of the structure that we're going to use to review the projects themselves. Hopefully everyone can see we're on the right screen here. And one of the key things that we'll talk about is, as I call it, the thinking outside the box. So you'll see we do a key criteria summary at the end of various projects here. And what that's supposed to do is to summarize the key criteria of all the components of a project. We'll talk a little bit more about what that means as well. But what I typically use that for, or people that I work with, or clients, is to try to identify both the strong points of a project and also what the weak points are. So the steps that we normally look at are, one, defining standard practice or prior art, or numerous terms, but what would be readily apparent to someone with a Bachelor of Science or equivalent in that field of science. Okay, and ideally we want objectives that go beyond prior art or standard practice. We call it thinking outside the box. Okay, once we do that, we ideally want to find what the CRA calls technological uncertainties, which are generally evidenced by variables. So, you could experiment with an infinite number of variables, but the engineer or scientist would say, I think these variables are the top 5 or 6 or 8 significant variables out of all the variables I could look at in order to experiment with. And once we define that, it's relatively easy to communicate to the team that, hey, anytime anyone's working on this combination of variables or understanding how they interrelate, that part of the work would be the related SR&ED, their experimentation. Okay, so that would be the analysis, results, and conclusions. Okay, so very quickly, the way we look at it is, first we wanted to find, do we have objectives, ideally quantifiable objectives, so we'll talk about why that's important, that go beyond standard practice. Okay. If so, can we identify 3 or more variables of uncertainty where we don't know, as in the case with Buehler, where there's system uncertainty, where a change in one variable could have an unpredictable upstream or downstream effect on the other variables or the performance of the system, and there's not a model that outlines that or provides clear indication of how that's going to look. Okay. Then if we do that, any of the related experiments, results, and conclusions would all be eligible. Also in your handouts where we look at the tax cases, we're going to give a reference, actual paragraph number, e.g. 54 would be paragraph 54 of the judgment itself, so that if you want to go back and reference any of the information that we've put here, you can do that quickly. Okay. All right, so skipping over the Buehler case. Okay. So the first case that I'm going to discuss is called Canafric, which is a food company in the food industry. Okay, so basically Canafric operates a food manufacturing business, and it works in Canada and the United States with a series of developments. The projects in question were a series of projects spanning from the 2013 right through the 2016 taxation years. And there was probably several projects each year. Now, what's important is that some of the projects were actually approved and others were denied. So it wasn't 100% denial. The client went to court arguing that the ones that were denied should have been eligible. So what we'll do is we're just going to look at one of the years, 2013, as opposed to all the years, but the projects in question tend to have a very similar structure. The 2013 tend to have the most evidence in it, so we'll use that as the example for discussion. Okay. So basically, across the series of projects, they provided a series of measurable objectives, and measurable objectives are very important, in my opinion, because the tax courts say that systematic investigation, one of the key requirements of the SR&ED, involves extremely accurate measurements and analysis of those measurements. So if you're not providing benchmarks or objectives that can be measured, you're going to be tended to be seen as doing what's called trial and error work, or work of a layman versus a scientist or an engineer. So the more accurate you can provide measurements and objectives, the easier it tends to be to show the systematic nature of the work being done. Okay, so in particular, In this case, the client across the products identified a series of measurable performance parameters, and they varied product by product, but they tended to look at shelf life, salt percentages, protein percentages, taste, which is something that we're going to talk about later, because there's both eligible components of that and ineligible components. Freeze thaw credibility, so the ability to freeze something and thaw it, and maybe multiple times, and maintain the integrity and safety of the food. Cooking time, and use of chemical preservatives are some of the key objectives that were identified in the projects in question. Okay. So the technological uncertainties are usually evidenced by variables. What's the typical method to do something? What are the methods that are used to do that? And how are we going to change this, and why, if we're talking about something that's experimental? Okay. So jumping kind of to the end, the judge felt that there was technological uncertainty at the end of the year. He said that each project consisted of new improved product where no information was available on how to achieve the goals. Okay, so he kind of shortcutted it, in my opinion, on how this would normally work in the review of this process. Okay, so the underlying key variables that were in question here, or argued, is what are some of the methods to achieve those objectives, to reduce fat, salt, etc. And very importantly, once we developed a method on one product, could we transfer that knowledge to similar products or semi-similar products? Okay. And that transferability of techniques was really kind of the basis of the argument that the CRA reviewers' position was that once they solved a problem on one product, it could be applied to other products, or at least similar products in the line. In the judge's opinion, this was not the case, and he felt that the ingredients would react differently in the different situations, so that the product methodology or knowledge was not immediately transferred. And we'll talk a little bit about why that is. So one of the key things that I always look at, or the course will generally look at, is the technology backgrounds of the principal investigators. Okay, so we're told that there was a Mr. Pandya, who's the CEO. In this case, they didn't provide us with a technical background, whether he had any. And if I look on the internet, I couldn't find any background for him. So we'll assume that he doesn't have a Bachelor of Science or equivalent in the field of technology, or that likely would have been mentioned in the case. Okay. Despite this fact, the judge found that the witness was credible. He was factual in his evidence. And one of the key things in this case is not so much the lack of formal training by the claimant, is that there was also perhaps a mismatch of the technical background of the RTA, or the CRA's reviewer who was reviewing this, who in the judge's opinion, based on whatever evidence was provided, and it's not completely clear what that is, that he may not have had the technical background to challenge some of these assertions. Okay. So taking a quick look at the 2013 projects as an example, what happened was 5 projects were claimed, 3 were accepted as filed, and 2 were denied. Okay, one for Asian style dinner and one for what we call the Costco deli chicken pie filling. Right? So those 2 were selected for review and ended up both being denied, and again became part of the claim that was challenged in court. If we look at the specifics of Project 1306, the pie filling, what we're told is that they were contracted by the customer, in this case Costco, and they had to develop a pie filling. We'll assume that they've got other standard practice on developing similar kinds of products in the past. We're not told what that is, but that would be relevant to the claim. That in this particular case, the product had to be boiled to 165 degrees to eliminate bacteria. Then it had to be frozen, put in 10-pound bags, and sent to Costco, where they were going to recook it. So there's issues on safety and things that come along with that. In addition, we're told some of the objectives is that they have to achieve a 10-day shelf life without using artificial or chemical preservatives. Okay? So again, in the knowledge base level, so normally what we look at is, well, what kind of due diligence work did they do to find out the methods typically available? Okay, and those would be things such as what would be prior art. So things like, did we look at competitive products? Did we look at readily available information, articles on the internet? Did we look at typical things for the food industry on how these could have been done, et cetera, and so forth? Okay, so effectively, we weren't really told here that the company did any due diligence work on any of its products. So again, that's a little bit of a anomaly for successful claims where this client actually won in the end of the day, that typically if you don't do at least some due diligence work as to what are the methods that are typically used to achieve these things, that would be a major shortcoming in my view on the eligibility. Okay. We're told that the technological uncertainties that the client proposed were to maintain product integrity and taste. And we'll talk about a little bit more about how those are typically claimed successfully in the food industry. Okay? So they talk about 3 different breaks, 1 freeze, and 2 filling phases. So there could be problems on integrity, taste, and safety after all of those. Okay? Maintaining shelf life without preservatives, and ultimately one of the objectives is to increase the protein fills of the filling by 35%, we're told in this case too. So again, these would often be objectives that would in aggregate stack up to create the technological uncertainties. We're not told it specifically what was done on a project by project basis, but basically within the case we were provided an overview of the development process for every product, that the customer provides a request with specific targets. So they would talk about shelf life, taste, acceptability, texture, things like that, ideally quantifiable. The company would then try to develop it, experiment with different recipes, and then test it via a test panel to see if it met the requirements. Okay. They then explained that if that product, if they could figure out a valid recipe, they might then take that product to plant trials where they would have to develop the method to manufacture it afterwards, and that there could be technological uncertainty both on the development of the initial recipe and on the development of the process to manufacture at a higher scale. Okay, and he clarified, Mr. Pena clarified that if they could not achieve the acceptable recipe, stage 1, they would not bother trying to manufacture it, which makes perfect sense. Okay. In this particular case, the recipe itself was unable to achieve the 10-day shelf life. I believe it got contaminated after 6 days when they tested it. So effectively, that project was unsuccessful and was abandoned. So no further plant trials took place. The arguments that the CRA used for denying the project was that the techniques that were being used here for reducing salt and the other objectives were developed on some of the other projects that were accepted and should have been transferable to the particular Costco product in this case. Now, what's interesting here is the judge went through a very detailed analysis using the 5 criteria. So these 5 criteria are used in some of the cases and not in some of the other cases. So this is an interesting shift in how the courts are reviewing this. But the 5 criteria were based on a landmark case back from 1988 called the Northwest Hydraulics case. And it developed this whole method. It was actually ruled on by Chief Justice Bowman, who was the head of the Chief Justice of the Tax Court of Canada at that time. And if you guys have been involved with us, I think in around 2018, he actually did about a half-hour presentation for us on this specific case and what he thought and what his beliefs were on it. So again, landmark case that's being referred to here over and over again in multiple cases. So there's 5 criteria that we'll talk about here. The first is whether there's a technological uncertainty. And in this case, whether there's risk, the judge felt that there was, whether there was a hypothesis created. So in this case, the judge said that the process, the development process that we outlined for all of the projects, in the judge's view, entailed the development of a hypothesis, so he felt that that base was covered. Criteria 3, did they use the scientific method? So the CRA took the position that there was a trial and error approach as opposed to a systematic investigation as required by the Act. Trial and error would be where you attempt different things and figure out that one works or doesn't without really understanding why something worked. So finding out what worked is the result, understanding why it worked is the conclusion and the technological advancement. Okay, so the judge felt that there was a systematic investigation, that when recipes wouldn't meet requirements, they conducted analysis to understand why, they modified the recipe, and they were limited in scope by clients' demands on which ingredients to use. Okay. The fact that they were unable to meet the targets is a business failure, but that doesn't mean there wasn't a technological advancement. That learning why you failed, the rationale for failing, would lead to technological advancement. So understanding why is the technological advancement, understanding what happened is really the result or the business advancement. Okay. Now, one of the key things, and we'll talk about this a little bit through the other cases too, is what kind of supporting documentation is applicable and how do we keep that? So in this case, the judge felt that there was both documentary and testimonial evidence, but more and more we'll find in some of the cases they're willing to accept testimonial evidence as opposed to written evidence in there. And we'll talk about the pros and cons for both of those, but just something to be aware of. Okay. In this particular case, and this is a bit of an anomaly here, there seems to be a bit of a diversion here in that the tax court put a fair amount of emphasis on the fact that the claimant had had discussions with the RTA, Mr. Zhu himself, as well as the manager, the RTM, and the financial reviewer, at which point we're told lengthy technical discussions took place that provided the information. And the client didn't really achieve an acceptable response. We're not told in the case what the content of those discussions were. So it's really hard for us to glean anything or to learn anything from it other than perhaps there was relevant information which could have been provided in the case study here. Okay. Based on this, the judge felt that, and I think this is a bit of an anomaly again, that the client had likely provided information in the oral testimony. We're not told exactly what that information was, but that the CRA failed to deal with that information in a forthright manner, and therefore the judge allowed this claim. Okay? So, as I said, I think this is a bit of an anomaly here. However, we'll talk about some of the things that I think could have been used to make this a little bit stronger. Okay? So one of the comments that I have is they talk about test panels, or what the industry would often call organoleptic testing, okay, which would be systematic. And this is actually something that there was an industry application paper done in early 2000s that was developed by both the Canada Revenue Agency and the food industry. So experts from both sides, where they provided examples of things that would be eligible as SR&ED and the rationale why. Now, those papers were repealed in 2012, so they're not readily available. However, I think they're still very relevant in the structure that they use, so I'll refer to it. And in the food industry application paper, they talk about something called FIMS, or Formula Ingredient Manufacturing Specifications, which is directly applicable to the case here. Okay, so they talk about that typical to the industry, when they'd have to develop formula ingredient manufacturing specifications, they would aim at project objectives very similar to what Canafric mentioned here. Product stability, consistency, flavor, texture, form, shelf life, safety, all of which would be often quantifiable, so they could provide our quantifiable objectives that we can use for our systematic investigation. They then differentiate between eligible types of testing, what they call organoleptic testing, where they have skilled taste testers. And this is very interesting that, you know, if you've ever dealt with those fields, the kinds of taste testing that they do are very systematic, where you can take these skilled taste testers and give them a sheet of, you know, where they'll rate bitterness, sweetness, mouthfeel, all kinds of variables of a new product, and rate it from 1 to 10, and they'll be very consistent. So if one of them says it's a 7, they'll usually say it's around 6 to 8. So it's a very objective and verifiable way of measurement, as opposed to taste testing where you take a product out, let's say, you know, to the public and ask people, do they like this new cookie? And they're not skilled taste testers, and you know that would be more of a subjective response as opposed to an objective, verifiable, measurable response. So the key differences between eligible organoleptic testing and ineligible more market testing can be a gray area. However, the more systematic you can be about this, the types of tests listed here, as opposed to things that are consumer research tests. Do people like it? What's the market size? Things like that. So again, if the company can focus on skilled organoleptic testing, which we'll assume that they have, we're not really told about this, that would be a strong indicator of eligibility. Okay. I put a link here if people want that. There's the pre-2012 examples, which you won't find on CRA website, but I think are very relevant by industry, are available at this link if anyone wants. Okay. So one of the other things that they talk about here is the 5 criteria in the Northwest Hydraulics case and how that relates to kind of the structure that I would talk about for SR&ED. Okay? So really what we want to do is to determine whether there's technological uncertainty, I think is a 3-step process. First, we have to define standard practice. Then we have to define objectives beyond standard practice. And then we can develop what the variables are that would illustrate that there was technological uncertainty. Okay? Whether we formed a hypothesis kind of leads to the first one. Step 2, can we talk about variables of uncertainty based on steps 1A and B, defining objectives that go beyond standard practice. One of the things that the courts talk about is, the precedent talks about, step 3 is, did we use the scientific method? Now, I find the scientific method is a term that I use all the time, and I really like it because I deal with, you know, clients and development teams that may be very, very cosmopolitan from around the world. So I may be dealing with someone, you know, who's from Europe one day, and someone from China another day, and someone from South America another day. One of the things that I find is universal. If I say the scientific method, every engineer and scientist knows exactly what I'm talking about. Objective, hypothesis, analysis, results, conclusions. I don't have to explain anything. So if I ask them to explain their work within that context, it tends to be relatively easy, both for them and to pull the information that's required for the CRA. Okay, so we'll talk about that a little bit more, but then we'll lead to, did it result in a technological advancement? A technological advancement within the context of the scientific method is the conclusions at the end of the day, assuming that we've followed all the other steps, that we've properly benchmarked prior art, that we've clearly identified valid technological uncertainties, and we've done it systematically to resolve those. So it does require, technological advancement requires all of the other steps to be followed, but it's actually the conclusion, not the result. So the result is the business advancement, and the conclusion as to why that particular combination of variables work is the technological advancement. And people often confuse those, which leads to problems in the claims. Okay, whether a record was kept or basically the documentation is one that falls again within what we call systematic investigation. Okay, so some of the key things are technological uncertainty. As we said, you've really got to go through this first 3 steps. To show that there's a hypothesis is often best evidenced by saying, well, look, there could be 100 variables that a crack team's going to identify as things that are relevant. But what we want to do is then apply professional judgment. So have the principal investigator, use his or her professional judgment to say, out of these 100 variables that we've identified, in my professional judgment, what do I think are the top 3 to 5 if I had to rate or rank them? Okay, and for the purpose of the SR&ED description, that's really what we want to talk about, because we want concise descriptions that are going to fit in the format of the form. Okay? The scientific method, as we said, is an internationally accepted definition which covers all of the components of a project. So if we start thinking we want to document our projects using the scientific method, it's going to very easily map, in my opinion, to the SR&ED criteria. Okay? As we mentioned, technological advancement is the conclusion, not the result. Okay? The result is the business advancement. The conclusion as to why is the technological advancement when we look at what the tax courts are really looking for. Okay? And documentation really is required under the systematic method. However, as we're going to see, the tax courts are very lenient. They'll accept any kind of documentation that's relevant. They'll accept stuff written on a napkin. They'll accept stuff written in other languages, as long as it appears to correlate with the issues in question. Okay? So if I look at what I call the key criteria summary, which is a little one-page snapshot to evaluate both the strengths and the weaknesses of a project, I can see here that there was really no benchmark. So when there's no benchmarks, there's no prior art search, there's nothing done here. Unlike the earlier case on Bueller, this is going to be a problem. What we did have here is we have objectives and results. So in this case, we had a shelf life goal of 10 days and we're told we only received 6. We want to reduce salt to increase protein, maintain taste. Ideally, what we want is put numbers, objectives to each of those quantifiable objectives, and then look at the results at the end of the day. Did we achieve the goal? Did we fall short of it? How far? Did we overachieve the goal? Did we get 200% of what we'd hoped? The further we are from our expected results, the more I would say that this is something that's worth talking about. Why did we see something that was unexpected? Can we explain, can we hypothesize why we saw these unexpected results? And those are good. So the results are good indicators of what the conclusions might be or where to focus on it. Okay, so in the first case of the product that we looked at, we're looking at methods to reduce fat and salt, transferability of techniques. Could we make conclusions on those? Yes or no? And it's the conclusions, as we said, the methods to do that that represent the advancement. Okay, when we look at methodology, how many things did we analyze, trials, prototypes, those are more in things that we would like to specify in the experimentation in order to justify the cost. So when a CRA reviewer is looking at a claim, they first start with what's called a desk review. So every single claim is reviewed by a CRA scientist or reviewer, and only a small proportion, maybe 15% per year, are going to actually have an actual site review. If the reviewer can do a desk review and say, you know what, I'm reading this and I believe, based on what they've told me, that there's all the criteria there's technological advancement, that's fine. But more importantly, or as importantly, if there is technological advancement, based on the work described, do the costs look reasonable or plausible? So the more details you can put on how many alternatives you did, what methods you used to do that, how you did it, it's going to be easier for the reviewer to determine whether that's reasonable. For example, if I say I built 12 different prototypes rather than several prototypes, and the reviewer thinks each prototype is reasonably 100 man hours, that's 1,200 man hours of work. Whereas if I said I built several prototypes times 100, I'm more likely to get a financial review because there's information missing, which is necessary for the reviewer to make an informed decision. Okay, so looking at this and where things are missing, these are weaknesses. If there's a blank area in here, this is something where the reviewer may have questions and they're going to come out and either ask you for clarification, or perhaps even worse, come and do a full site review. Okay? So in this case in particular, I found it was an unusual combination of lacking a Bachelor of Science or equivalent in the field and written documentation. So I mean, some of us, I remember 6 or 7 years ago, there was a case called FlavorNet that lost, where it appears, in my opinion, much stronger than this case. So the fact that that case could lose and this case could win, again, shows that there's some variability, in my opinion, on the judgments themselves, and that some judges may be more favorable, particularly to small business, than others. Okay. Moving right along, the next case we'll talk about was translated from French. So we'll talk about how that creates some issues in the interpretation at the start, but it was dealing with a concept to do thermal storage. So what we're told is that the company, sorry, there's a bit of a confusion here too, country called Hydro LMR created a project to analyze a thermal system. Now, when we look at the case name itself, it's under a company called ACBK gestion, or basically a different legal name. So one of the key things is, well, how come the contract's for this company name and it's being claimed by another company? What I did is I did a title or a name search and found that the individual in charge, the primary investigator, in this case, Mr. Roy, is involved in a whole series of companies. He's connected to dozens of them. And what I'm going to assume, because we're not told here, is that somehow those companies were connected or related in some way. So when we refer to one company, it really will refer to both of those. Okay. So what we're told at the knowledge base level is that in a prior year, another individual had developed and patented a system called the Hydrodynamic System for Energy Efficient Assistance of a Building. Okay? This is a Mr. LaPerle, and he received a patent. I think it was 2007, 2009 area. Okay? A couple years later, someone from Mr. Brunet from, they call it CREEC, which is the Center for Research and Industrial Development in Quebec, approached the claimant here, the appellant, Mr. Roy, to ask him for ideas on how to improve the system. So they went out, they did a site visit, and looked at the Mr. LaPerle system, and Mr. Roy decided that he liked the idea and had ideas on how he could improve that system or created an improved version of that, and he went out to prototype. We're also told in this case that before he embarked on this, he talked to a Mr. Roos, who was again another expert of the field in industrial research, to carry out numerical simulation on the project and determine what the problems were, and based on this analysis to scale it up to a life-size prototype. So these are all, in my opinion, relevant issues. Okay. So Mr. Roy decided he's going to use develop the life-size prototype based on the patent and the notes that Mr. LaPerle had for his previous system, but he identified problems in the use of that system, specifically the temperature of the water in the tanks, prevented the pumps from working properly. He thought there was issues on the size of the tanks, the lack of probes in there, and a method to program or control the panel. Okay? So out of those problems, Mr. Roy said that in his opinion, the technological uncertainties were the size of the water tanks and the temperature of the water. What my takeaway was, looking at all of that was done, that the tank size and the water temperatures were relevant, but one of the other probably more important issues that really wasn't discussed here was the orientation of the basins itself. Okay. So we're told that Mr. Roy was the president and sole director of the company. This is, again, when I translated the judgment from French, it said he's an electromechanical by training, and I didn't know what that meant. An electromechanical technician, electromechanical engineer, et cetera, and so forth. So again, normally we would know, does that individual have a Bachelor of Science or equivalent in the field or not? Because there would be a difference between an electromechanical engineer and electromechanical technician. Not that both couldn't qualify, but again, they would tend to look at the scope of a technician, whether he or she had the requisite knowledge, a little more closely. Again, so from the results of this case and the problems in translation, it's not clear exactly what the background of Mr. Roy was. Okay? We're further told that his background involved designing and installing automated systems in the food industry, okay? Not in the construction industry, which again could be relevant to this case. So what did he do? Mr. Waugh went in and first he said, well, our experimentations were going to change the size. We built a full-size prototype. We'll change the size of the various pools. We'll install probes to measure. And then what he did is he started changing. He inserted the smaller of two basins inside a large one. So the actual orientation of the basins. He installed a third basin. Okay? So again, even though he didn't identify the basin size, shape, geometry, and layout as one of technological uncertainties. When we look at what he did, it appears that this could have or should have perhaps been one of the bases that he argued in the description. Right? And then we're told he installed and programmed the control panels. So again, one of the things I'd say here is usually things like installing probes, programming control panel are not technological uncertainties. The fact that a system didn't have it before, but you know you want to install the probes, unless there's some specific uncertainty on how to install a probe or how to program a control panel, those tend to be routine engineering issues. Having said that, the cost for doing that would automatically be eligible if the project is eligible, if you can argue that it was necessary to complete the work. So if you said, well, I couldn't finish my testing without the probes and the control panel, then that would just be a necessary supporting activity that didn't really have to be described in any further detail. Now, according to the CRA, Mr. Demeray, who's the expert witness, the work done could have been achieved using known thermodynamic principles, equations, etc., to model heat exchange, heat flow, and stuff, to estimate the dimensions of the basins, and that he or she could have used a scale model instead of a full-scale crater to do that. Okay? The RTA, in this case, Mr. Demeray, also referred to Mr. Raprole's patent and said that within that patent, there was not only that patent laid out some issues, but there were other patents cited which had similar systems available since the 1980s. Okay? So that's a good point. So ultimately, based on the evidence provided by Mr. Roy, the judge felt that the techniques used were standard techniques for the construction industry, again, which Mr. Roy did not appear to have a background for, and that in his testimony, he wasn't able to describe precisely how the techniques to overcome the uncertainties represent a technological advancement. Okay? So the modification of the size of the pools, installation of probes, valves, and a control panel, he said, would be typical for manufacturing of that in any of the industry. So again, there was not enough detail on what specifically was there to show that we went beyond the standard practice. Okay? As a result, they lost. And looking at the overview, we can say, well, again, one of the biggest weaknesses here was, or the biggest weakness was a lack of review within the case, within the arguments of the court itself, of the definition of standard practice. So just saying we relied on the patent and didn't really do any work on what are the typical methods, what are competitive methods, et cetera, and so forth, we didn't do enough due diligence work. Okay? Even though we've identified variables such as basin orientation, tank size, and water temperatures, there wasn't enough of a correlation that went beyond standard practice to convince the judge in this particular case. Okay? The only real objective that they provided as a measurable was they wanted to increase efficiency. Okay, and again, we didn't really see a lot of evidence of extremely accurate measurements and work on how far or how short they fell within that. Right, all of which would be stronger evidence to support the case. So looking at this and saying, okay, well, what can we learn from this as claimants or practitioners? And how could we have maybe taken the existing fact scenario here and turned it from a loss to a win? One of the things I would recommend is we could have got expert testimonies from Mr. Brunet. There was actually the fellow as well who did the industrial study, all of what the numerical study up front, both who were government researchers from industry and would have been strong witnesses. So again, why the evidence that they brought up, or perhaps even using them as professional witnesses, did not seem to weigh or have the information to allow them to tip the scale here, but I would have focused more on that. One of the other things that we said is that when you have a patented product, I don't understand why Mr. Watt didn't refer to that patent and maybe look for areas specifically that he could pinpoint for the uncertainties. Now, let me just go here. So what I did is I very quickly went in and I knew, we were told that Dominic Laperle invented this, so anyone can pull a patent. It took me seconds to find this patent. I could find that Okay, here's the patent. Here's what it does. It talks about building, creating a hydrodynamic system for industrial buildings comprising at least one hydrodynamic basin, proportional to inertial force. So he's already talking about theoretical things. Inertial forces created by the basin, and so things like how to model that, how much force we needed, et cetera, and so forth, would have been relevant to the claim itself. And had we focused more on that, that would have been interesting. We talk about exchanging heat exchanges between thermal masses, again, and using refrigerated elements, which was not talked about in the appeal itself. But we're also told in here that it was constructed using known techniques. So again, the cutoff of where do we want to focus on potential technological uncertainties, and what things might have been more relevant here. Okay. We're told that Mr. Demarais, the RTA, also said that that patent had cited other patents, which it did. So you can go down and look at similar documents. So had Mr. Waugh gone in and perhaps reviewed these patents, and it wouldn't take long. I mean, we're probably talking an hour or two to go through and talk about why some of these are not relevant, they're in a different industry, or they don't apply, or perhaps even better, find 1, 2, or 3 that may be similar and create ideas, but then talk about this is a good idea, or here's different ways to achieve the same thing using different methods. Here's why method 1 wouldn't apply, here's why method 2 wouldn't apply, here's why method 3 wouldn't apply. However, even better, and this is typical of eligible projects, even though method 1 wouldn't apply, there's a concept here which might be applicable. And even though method 2 wouldn't apply, there's another concept which might apply, and various things, where we may take different concepts from these ideas and combine them together to achieve the goals. So we would be using different areas of other practices, combining them in a unique way to achieve the goals. That would be a strong indicator, in my opinion, of technological eligibility. The information was there to do this, it just wasn't leveraged in this particular case. Okay? When I go through the patent itself, it provided a 14-step overview of the various components of the system, which I've provided here, and which also could have been used to identify the key areas of uncertainty within there. So to evidence this, the figure 1 had 14 different steps that we'll look at here, but some of them weren't mentioned in the case study, and I think would be relevant. So one of the things is that we want to have as much of the orientation facing south. So that wasn't mentioned. That could create a technological uncertainty. We're also told that the hydrodynamic basin had to create thermal inertia containing stones of 5 1/4 inches to 21 1/2 inches. So this was not mentioned. Why that particular size? Was that particular size relevant? What kind of stones? What was it? Limestone? Did any of that have a relevance? So those all could have been relevant factors to talk about as the technological uncertainties. We talk about overflow levels. We talk about the temperatures between 35 and 65 degrees. So again, all of these things, if it's questionable, or if we're arguing maybe this isn't the best way, could have been very relevant and added a lot of relevance to the current claim. Okay. We're also told that the mechanical room was all made out of prefabricated areas or prefabricated device. So looking at that, I'm saying the area related to the mechanical room probably didn't involve much of the technological uncertainty, whereas the case itself focused too much on that. We talk about the access pump, external sump pumps being related to the type of soil. So again, there was no mention of type of soil, but perhaps that was a potential variable of uncertainty that would have been relevant. Okay. Then they actually talk about the thermal slab itself for distributing heat, for accumulating heat transfer, and its location at the bottom of the basin for refrigeration as well as heat. So again, all of these things, the foundation, design of the foundation itself, the use of a submersible pump, having undisturbed soil, and having the thermal panel connection in there. Any one of these could have been potentially technological uncertainties that we could have gleaned from the original patent to talk about more in what we're doing to improve on the technology of the patent, as opposed to just recreate it. Okay? One of the other things that they talk about in the patent itself, the original patent, by Mr. Pearl is they give us the numbers that we need. They give us the objectives that we could be trying to improve on. So we're told the space of the house, the insulation that was used, that they had 6 specific types of solar panels, what the ratings of those panels were, and that the result was energy savings of 45 to 50% and savings in drinking water of 95%. So again, measurable performance objectives that we could be trying to improve on, or at least try not to degrade as relevant evidence in the cases. So again, that wasn't done from the evidence that I see in the court. Okay, next case, mold leaders. So the facts of this case is that it dealt with 2 taxation years, 2016 and 2017. During that period, mold leaders was engaged in, we're told, approximately 320 projects, of which 8 were claimed as SR&ED, and the balance were seen as routine or normal business. Okay. We're out of those 8, we're just going to look at one of those projects because the theme of it is relatively the same throughout. So the first thing that we want to do is look at the principal investigator's background. What was his or her technical background? In this case, it was a Mr. Duong, and we're told that English was his 4th language here. So that I'm saying these things are all relevant in the interpretation and the ability to explain things. And we'll talk about how you want to address this by having the information prepared up front so there's no interpretations, particularly where you're relying on verbal testimony. Okay, as in some of the other cases where the judge felt that the verbal testimony was very strong. If there's language barriers, again, it's really important to prepare that information up front, document it so that there's no misinterpretations. We're told that Mr. Duong graduated from a 2-year mechanical technician program at Humber College, that he worked in the industry for a series of years, and then ultimately he developed his own company based on roughly 5 years of experience in the industry. They tried to include an expert witness in this. However, the problem in this particular case is there's a number of criteria for expert witnesses. One is that they're objective. And in this case, the expert witness was also the person who prepared the SR&ED claim. So that would question your objectivity right there. The second is, do they have relevant experience in the particular field of science? And though the expert witness in this case was an engineer, his background was not in the field of science, and therefore the judge felt that wasn't relevant. Okay, so he didn't have relevant knowledge in plastic injection molding industry, and as well there was probably an objectivity issue. So they did not value that particular expert witness. One of the other things that they mention in here is the client made their own mistake of calling their work trial and error, which just highlights to everyone that you didn't read any of the CRA's instructions on how to document an SR&ED claim, because if you had, you wouldn't have used those terms. The courts also call trial and error the opposite. That's the antithesis of systematic investigation. Trial and error is what a layman does, where they try different things and hopefully they get lucky and find the result without understanding what happened. So as we said, that's the antithesis of what's required, which is systematic investigation, which involves extremely accurate measurements. And when something fails, you try to understand why to revise your hypothesis for the next trial. Okay, you're not randomly trying things, you're systematically trying things to build on your knowledge every single step of that process. Okay, so do not use the words trial and error in your project unless you're on the CRA side trying to argue why it's not eligible. Okay, so this word should never appear in an eligible project. So what we're told is that in this particular project, we'll call it Project 1, the client got a contract with the customer called Dynaplast to develop a 4-cavity mold to manufacture a valve in the automotive industry. Okay. So when they work with this, they found that this particular part was different than what they were normally used to. And here, I'll wrap this up quick. And as a result, they couldn't use the steel in question. What they did was they worked on a different type of steel. So we're not told that they did any due diligence work in this case. They moved to a higher steel called a 360 steel, which they didn't have any information on. That they ultimately did 6 iterations of a mold, and it was basically ultimately accepted by the customer, and we're not told why. So when they interviewed the customer, again, we're told Mr. Duong had English as a fourth language. When he was asked what the uncertainties were, he basically said that he didn't provide any specifics. He just said that, you know, it was complicated. So again, if you're going to not have written testimony, your oral testimony has to be strong. And just saying that we learned something, but not being specific about what that was, is not going to provide the degree of oral testimony required. Okay? So the judge, again, commented that because we hadn't benchmarked the state of existing knowledge, it was difficult to know if there was a technological advancement. As a result, the case was not only dismissed, but dismissed with costs, which means that the claimant has to pay additional fees for the court costs incurred on that. So again, that's not only a loss, it's a really bad loss, and you want to avoid those. Okay. So again, when I look at the key criteria summary, really there was very little on in terms of benchmarking. There was really no variables of uncertainty used, and really the objectives could have been expanded on a little more. Okay. What I've done here is just provide a quick overview of what the company could have done to make this a little better. So on a quick review, I found an article on factors affecting machinability of metals. So on this type of work, they talk about machinability of metals, including things like materials, feeds, speeds, cutting fluids, rigidity of the tool device, microstructure, grain size, heat treating conditions, chemical compositions, fabrication methods, etc., and so forth. Had the claimant talked about these kinds of things, we probably would have had an eligible claim. So if the objectives were looking at, you know, tool wear, consumption, surface finishes. So they say that even defining what machinability means has different terms. We want to find it being able to achieve a surface finish, or the power consumption, or the tool wear, or a combination of those things. Again, all very good things for strong SR&ED projects in there. Okay. We're told that those influences affect each other, that things like tool geometry, cutting operations, metallurgical structure, different cutting and cooling fluids are all relevant variables to achieving this. And this is an industry paper saying these are problems indicative of the industry. So the more that you can face or identify those kinds of things, the more likely this work would have been eligible. Okay, it provides benchmarks on things like the power required versus the materials for hardness of materials. So things that are standard, you can go in and say, well, here's how we normally do it, but in this case, things are a little different. Here's how we're going to change it. The company may have been eligible in that case. Okay. I'll just hit through the last two very, very quickly, Earl, and we'll wrap it up. Dave's Diesel was basically another one where the company was a fuel injector shop. Again, the appellant really didn't have a background in engineering or science, but what they did is they would refurb or remake, refurbish certain kinds of components for injectors. Okay, so the judge noted that Mr. Dave, who is the appellant here, who is the general manager of the company, which was started by his father, but he didn't have any background in mechanical engineering. His background was in business and marketing, so that should raise a red flag right there. Okay, what the appellant wanted to do is figure out whether they could manufacture or remanufacture injectors from different companies, Volvo, Caterpillar, and Cummins. But again, we're not provided any analysis of due diligence work or the knowledge-based level. Okay, we're further told that there are technological uncertainties whether they can develop something. Okay, so that's what they call a scientific uncertainty. Can we do something versus a system uncertainty, which is how are we going to do it? Right? And when you talk about scientific uncertainty, those projects tend to be less eligible than ones where you can get more specific on how to do it. Okay? So the notes itself, as we said, are really concise diary entries rather than the notes that they would expect to be evidenced here. So they give a series of little notes that the client provided as their diary of work. Okay? And provided oral evidence in court. Now, what the judge says is, well, taking those notes, you know, you talk about shim thicknesses as a test. And the judge said, you know, ideally we talk about more specifics. What thicknesses were tested? What were the results? What was the standard for testing those? What pressures were tested? How long were they tested? When did they fail? There was no record. So again, the records provided to the court didn't show evidence of experimentation and analysis. they more or less provided evidence of a step-by-step process. Okay? That in the case itself, they provided evidence of one of the handouts that was provided, but again, this didn't correlate to the test itself, so it wasn't relevant. Okay, so really, the judge felt that they hadn't kept a relevant evidence of the hypothesis, and therefore the work was routine engineering. Okay? He felt that because several non-engineers didn't know about it, was not relevant. The question was, would someone who had a Bachelor of Science or equivalent in that field of science feel that there was a technological uncertainty? Okay? So he didn't feel that understanding how a fuel injector worked was anything but a standard procedure. And the work should have been focused on understanding how they work before you did that additional work. Okay? So again, the key criteria summary, full of blanks, as we could say, no benchmarks of standard practice, fewer quantifiable objectives leading to a problem there. The last ones, or one of the last ones we'll talk about in the welding industry, is we had a company that focused on welding products. They had 3 appellants testify who the judge felt were technical witnesses, but again, we're not told that they had any technology backgrounds. The key question here, we'll look at one of the projects, is whether they could take a welding line and add a series of sensors to improve the welding process. Okay, they said if they could actually put these sensors through the system, they would also figure out whether they could predict whether a problem was going to rise. What they did is they tried it. They approached the company to install the different sensors, but they found that really the problem was that they couldn't connect to the client's software because of proprietary issues, which is more of a business problem than a technology problem, and therefore not really an issue on whether that would work. Okay, so having different communication protocols would be more of an advancement in software engineering than in mechanical engineering. And the judge felt that they really didn't know whether, had they actually hired either an electrical mechanical engineer or a skilled computer engineer, whether those people would have been able to address the projects. Okay. Last 2 projects really quickly. Chagnon is a corporation where they were developing molding for jewelry. However, the claimant admitted she had no knowledge of the field of molding as at the learning stage. So again, it's not a learning process, it's an advancement process. They just didn't have the relevant skills. Okay. The last of them, Quebec company, what they did is they hired a subcontractor to do all the work. And the subcontractor, machinery design company, they may have faced some problems. However, the company wasn't privy to it, nor did they provide that in court. And as a result, they didn't have the evidence. Okay. Cooper's Park Real Estate is one related to GAR. I'm not really looking at it, but basically what happened is the company was denied some of the claims, probably because same or similar business or whatever, and they didn't provide information. The judge felt that, hey, there was a big fight between CRA and ultimately gave him the right to continue that. All right, Earl, I'll leave it at that and we'll switch over.